Hello everyone, welcome to another episode of Talkative Strangers. Today we have with us Nelson Herbert. Thank you so much for coming. Would you like to tell the audience a bit about yourself?
Thank you for having me. My name is Nelson, as introduced. I graduated with a bachelor's in mathematical physics in 2014, and I've done like a couple of public talks on physics and stuff, but not for a while. So I thought I'd come on your show podcast thing when you invited me.
Okay.
That's great.
So I was watching your video from Ignite Cardiff. I think that the
Yeah.
video you uploaded talked about basically the Big Bang theory. So
Yes.
there was a came up into my mind. The video was actually so good, but there was something that came up to my mind was the universe is basically composed of energy, mass, and all the basically mass and the particle, and the
Yeah.
energies contained or conserved in that domain only. So the Einstein also gave the equation that you also wrote in that video. But below that
Yes.
equation, you also put the equation that universe is zero. It is nothing. So can you explain a bit how the universe is nothing, and despite the fact it has so much energy contained in itself that it actually constantly expanding and expending its energy at every time, which is faster than speed.
Yeah, certainly. I'll do my best. There's a lot in that. But yeah, so the equation you're mentioning is that total change of mass energy for the whole universe is always zero, which is one of the laws of thermodynamics. So whenever you run any kind of system, an engine, whatever it is, the total change in energy from like potential energy stored within it is zero if you include all the heat that's lost to the universe somewhere. And what my talk was about was how, despite that always being true, the Big Bang happened, and now we have a universe. And that seems that they can't both be true, but obviously they both are true because thermodynamics works, or our engines and stuff will break down. But also the universe is here because me and you are talking now. So the way that's true is because of negative energy, to put it simply. So if the total change in energy is always zero, you can add 5 energies as long as you have 5 negative energies as well, because your total change is still zero.
Right.
So as long as you can have negative energy, which exists, it's called potential energy. So you have, I'm sure I know you guys are studying physics at the moment.
That's the negative potential energy.
Potential. Exactly, potential energies. So you get like electromagnetic potential energies, loads of elastic potential energy, which makes like elastic things snap back. But the universe's main one is gravitational potential energy. So things can fall off shelves, and if they do, they'll accelerate. They gain energy.
Right.
And as a result, there are negative potential energies, as you called them, Shrey. Yeah, that's right. And because those got created when the Big Bang happened, because you got large masses that got a distance between each other, and they could collapse in on each other. As the Big Bang, the whole universe could collapse in theory. Everything could come together. So as the objects moved apart really fast, that's creating the negative potentials. So that things got created and expanded because it created the negative energy doesn't actually violate thermodynamics.
Okay.
So if that's I hope that answers your question. It's not an easy question to answer, but that's that's my answer.
End of science, basically. End of physics, actually.
Yeah.
Yes.
So, talking about Big Bang, how exactly Big Bang started? How did something emerge from nothing? And Big Bang is still a theory. It's not yet proven. So do you think Big Bang is the only theory that can prove how universe began? Or do you think that there might be something else also?
Oh, right. So I would disagree when you say the Big Bang is just a theory. It's not proven. People have won the Nobel Prize for proving that Big Bang happened. So the way we know it happened is what's called cosmic background radiation.
Right.
Which was the radiation, the light and heat from the Big Bang has a certain pattern, unlike anything else. And we can detect this. And this is detected by scientists, I'm pretty sure, before any of us were born. so you can effectively see the Big Bang still happening through like radio satellites. So the Big Bang is not just a theory; it is proven. It did happen. As to
how did it happen?
That's
Yeah,
a harder question. That's a harder question to answer. So within things like how did it happen, there wasn't a thing before. So when people say what was the universe like before the Big Bang created empty space. It kind of created time. So there wasn't a before the Big Bang. The universe has always existed. Because there wasn't like a blank space with nothing going on. The empty space didn't exist yet.
So there obviously which basically expanded, and we also made that in some sense.
Yes. So there's a finite amount of empty space within the universe. It's enormous and it's constantly getting bigger and really fast. But things like time and empty space didn't exist before the Big Bang.
Okay. So there was no time also.
Yeah. So that's might not exactly how it happened, which was I know your question. But that's a very difficult question to answer. The best I can say is going back to thermodynamics. One of the other laws of thermodynamics is that things always become more chaotic, or stay as entropy. Entropy always increases. So the Big Bang makes entropy go up. So if the laws of thermodynamics were present, the Big Bang is inevitable because it makes so much entropy.
Right. Okay. So yes, and moving to our basically the next thing that came to my mind is after Big Bang happened. So how did basically actually life emerge on our planet only?
How did life emerge from a non-living matter?
Right.
Okay, so that's so like on our planet only, you said. So I'm not sure there is only life on our planet, but we've definitely not. There's no proof. There's no proof of life anywhere else. There's no proof of life anywhere else.
Right.
There's no proof. There's no proof life itself. But there could be.
There could
however, however, how life came onto our planet. So obviously, there's a very long answer. How planets form and everything. So the planets formed already. I'll start.
Okay. Yes. And now the unicellular organism.
But there's nothing like alive on the planet. So Earth then was was more hostile than it is now. It was more the volcanoes going off, and I think there'd probably been a bit less land mass and stuff. It's not my area. But one thing I do know about this, and there's an experiment done in the 60s called the Miller-Urey experiment to kind of replicate this, is that there were lots of lightning strikes because volcanoes were going off, upsetting the atmosphere, stuff like that. Now, what the Miller-Urey experiment did is you can take non-living matter and electrocute it by lightning strike. And this doesn't exactly create life, but it creates from non-living materials. You create self-replicating enzymes and proteins. So whether exactly that's alive is a different argument. But once you get proteins that start replicating themselves, eventually you get proteins that start replicating themselves with cell walls and stuff around them, and that's so that's how you go. We believe anyway, and it has been experimentally backed up. We went from not having anything that could do that could self-replicate to something that could.
Right.
So is it possible to do the same experiment in a lab right now? We electrocute something and
yes, it was done. It was done in the 60s. It was called the Miller-Urey experiment. That's what it was called, or something similar to that. And I believe it had that out of it became proteins that we hadn't seen before. Out of their sealed vats they had with ooze in them that they were electrocuting. And there weren't self-replicating proteins in there, and then they were making enzymes or something. They were able to build the basic blocks of life.
Right. So this is the only answer for life emergence.
Yeah, that's the only answer. That's the best answer we've got. So it's from basically rough organic, carbon strings getting electrocuted. Changes them into.
How basically the survivability or the other consciousness basically ingrained in the organisms. That is also one of the mysterious part of the life.
What survivability?
came from single cellulose.
No, basically, my question is that how basically protein know that it has to survive, and what are the ways by which it can survive, and what is the need of surviving? So
what's the need of surviving? What's the meaning of life?
right,
But
kind of.
there isn't one. But the ones that do self-replicate keep self-replicating.
Right.
And that's not a very satisfying answer, but it's simple and true. It's not that they have a need to survive, but the ones that did survive and kept replicating are the ones that kept going. So that's all it was.
It will gradually survive.
Yeah, some of them, a lot of them obviously don't, but some of them did. And the ones that
So
did are the ones who
algorithm that is being run, that you can say that.
Sorry?
It's a kind of an algorithm that is being run that from protein there will be this life form that will be formed. It kinds of a simulation that you also can say that. Do you believe in
that everything is kind of planned?
A plan.
Well,
that this is going to happen.
Right.
Well, if it is like a simulation, it's a chaotic simulation.
It is chaotic, but might be not for the other person. Chaotic for us, it's random for us, but not for the person who is actually running it.
So this is more biology than physics, but there's a book by Richard Dawkins on this.
Which one?
Called. So there's a couple, but The Blind Watchmaker is the best one for this.
Blind Watchmaker.
Right, and there's also the River Out of Eden is a very good one for that, also by Dawkins. But in one of those, he explains very well something called junk DNA.
Okay.
Yeah, more specifically, the junk DNA within mitochondria. And mitochondria aren't us; they're the bacteria that live within our cells. But they're smaller. It's a single cell bacteria, smaller than a human cell, and it lives inside our cells. Because those is less subject to complicated stuff. They don't, interbreed in the way other animals do. That's more complicated, more interesting combinations. Mitochondria don't get that because they just live inside our cells. But the junk DNA of that, so the DNA that doesn't really affect how the mitochondria behave, mutates randomly. So across different animals that have been distantly that are not closely related, the difference in that DNA is random. So that implies that things like evolution are not pre-planned, that they are in fact forces of random protein changes.
Okay. So that also was given by Charles Darwin only, the natural selection theory of natural selection. It is somewhat like this.
But that randomness can also be programmed in a way that it might seem that it's not pre-planned, but it is actually pre-planned.
Yes. You can never be sure that something's not just pretending to be random.
But at some point of time, we humans are, I don't think we are basically the randomness of the nature, because we are so much complex, and at this stage, our primitive genes are also living in environment only. So despite that fact, we are also existing in this environment, having so much complex things or whatever you call it. So that can also be one of the reasons to making humans such a complex organism in this world or in this deep planet.
Well, yeah. Humans took 4.5 billion years to get humans. So
humans, right? But still, for that matter, also, we are so much evolved, and there is no need for that extent of evolution actually.
No, there is no need. It doesn't happen because there's a need for it to happen.
Right.
It's just the logical conclusions of the universe.
Sisters are also living at some point of time. But why was our sisters are also living, but why was there a subtle need for basically to DNA to mutate in some sense that we actually evolved language and then discovered fire and many of the things that have been happening to human?
That's an interesting one. Language in particular is an interesting one.
Right. The language.
Because by a lot of measures of intelligence, a lot of primates would outperform humans. Gorillas have better memories than humans have, for example. But we have much better language.
Right.
Gorillas have a very limited vocabulary, maybe 100, 200 sounds they can make to each other. And it's, you know, there's food over there, there's a snake over there. That's all they can say. Whereas we have language, so we can have complicated ideas, figure them out, and then explain them to someone else. So even if a gorilla could do physics, could do philosophy, it couldn't figure it out. It couldn't tell any other gorilla, so it would die with that gorilla.
Right. Only genes can tell him.
Sorry?
The genes can tell him. The transfer of information will take place through the genes only, in the genetic matter.
So yes, you do get information transferred through genes, but you can't do that for things that you've thought up in your own head.
Right.
You get things where, like, animals are born instinctively frightened of the smell of other animals. They know that smell is dangerous to them. But that's not like a kind of science thought. That's not the same kind of thinking that humans do.
Right.
So yes, you can have genetic, and you can be born knowing stuff, but that's not the same as what you figured out. That's not our philosophy. Our children could never know this conversation from our genes.
Right. They'll gradually, basically know them about through language or the culture, which they will get shaped.
Sorry, what was the question? Sorry, you're echoing a bit.
I'm telling you that we gradually, we transferred information through language only, in case of humans, not through genes. The information we transferred through language or memes, basically the culture.
The information, what we class as information, the information our society is built on, is transferred through language. There's basic things like that humans are born knowing stuff that's been passed on from our parents. We're born not to fall, for example. Babies cling to their mothers, and they do that all around the world. It's not something that we teach them when they're very young. We're born knowing to do that. But the knowledge, when we say like knowledge, information, what we mean is, you know, how to cook food, how to build stuff.
Right.
That's what we mean by knowledge, really, isn't it? And that's language, not genetics.
To basically increase our chances of survivability. That is the main knowledge.
Yeah. Well, humans have kind of people say that humans have kind of gone above that recently. But for every other animal, it's definitely true.
Right. Kind of.
Yeah, humans are not now focused on survival. They have other things to focus on now.
Yeah, humans survive very easily. We have a much higher. Our children survive to adulthood at a much higher rate than any other species. Because we have, you know, medicine, and we don't have predators.
We have everything.
Yeah. So, like even like lions and stuff, a lot of their children, you know, starve to death and things like that. At least a lot more in comparison to humans.
But we know the best way of communication. That's why we are basically more survivable than other animals.
Yeah, that seems to be it. And I don't know why it happened like that, but that does seem to be what it is. Language has given us a distinct advantage over every other creature.
Right. Language is the main reason that we are humans. We have evolved so much because of language.
Yeah, exactly. It's why we can build. It's why we figured out to build buildings and the electricity and internet. And
Right.
And gorillas
But
can't do that.
any idea of yours? So how actually language evolved? Any speculation that is?
No, that's really not my area at all. I mean, it's gradual step by step things. Like our mouths are different shapes to gorillas. So gorillas can't speak like we can. They can never learn to do it. And there's always that incremental steps. It takes hundreds, thousands, millions of years.
Right.
But if you can have 1,000 words over 100 words, you can communicate with your cave man friends a bit better, or your or your ground dwelling furry people, whatever stage of evolution it was at.
Right.
Then because you can then say, don't tell people like don't eat that fruit, it's poison. And if you can't say that, your children will eat it. So it's step by step.
Right.
And as soon as you get a bit better language, it becomes beneficial. I mean, you have things. Another one you mentioned earlier, Shrey, was fire. So fire, obviously, you can explain to people through language how to keep fire alive.
No, I don't think. Fire was discovered before language, according to me. I'm not sure about that.
I think it's.
Fire was discovered earlier.
Well, very depends what you mean by language. Very primitive creatures had at least some language.
Okay, that can be said. Indexes, symbols were used, I think, for the sake of language.
Yeah,
that is actually used by our primates.
Fire was before written language, certainly. But the people who had those fires could grunt at each other and communicate.
Right. That you can say, but not the complex.
Oh no, but once you get a tribe that can explain to each other how to keep fire alive, for example, because if your fire goes out back then, your whole tribe could die. You could freeze to death. You could not be able to cook your food. So if you have a tribe that can explain to the younger members how you keep the fire going, that tribe might be slightly less likely to die. So it's steps like that. It would be my theory as to how we got language.
But somehow I read in a book that gradually the fire was the only reason which led to the development of our brain only. And after the development of brain, our amygdala, or there was some part, I think hypothalamus, I don't know the exact term, which gradually evolved, and we basically inhibited language. So first fire came because the cooked food, basically most of our energy was used to digest food only. And by the time it got cooked, so the energy went to the brain. So our brain got developed.
Oh yeah, so that quite possibly.
Yes, energy dissipation was directly transferred to brain, which gradually led to the development of brain only.
Yeah, quite. That seems quite reasonable to me.
We adapted other things gradually.
Yeah.
So first it was sign languages. By hand, we were used to communicate by gestures. And then we built tools. When we had tools in our hands, so there was something basically to evolve to basically communicate. Then our mouth basically developed in that way. That larynx got developed, and then pharynx and the other part of the vocal cord. And then it produced sounds. And it became gradually complex.
That's probably right, because non-tool using primates don't have a larynx like ours.
Right.
Like gorillas and bonobos and stuff, they can kind of screech.
Right.
But they can't make the same distinction in noises that we can make.
And
they communicate mainly through like pointing, don't they? When you see them in the zoo, they go like
that. Right.
That's yes, Aryan, please.
So as we were talking about Big Bang before, so people say that something might have caused Big Bang, and then they say God might have caused Big Bang. So
the creator,
not the answer to God.
We are talking about the creator. We are physicists.
So I can't tell you what caused the Big Bang. As I said before, the best answer I would present is the thermodynamics. That in order for the Big Bang makes entropy go up by a massive amount from no entropy in the pre-Big Bang. And the law of thermodynamics is that entropy stays the same or goes up; it never goes down. So that's why the kind of logical conclusion I have as to why the Big Bang happened. I can't disprove the existence of God. That's a difficult one to do. But the universe, and there are certain aspects within the universe that have to be the way they are. I don't know why they are. The best example I have is the ratio of mass between, say, an electron and a proton. Because those are constants within the universe. Every electron has the same mass. Every proton has the same mass. And what that is matters. All chemistry, everything, all the building blocks of life, all the protein stuff I said earlier, would all not happen if that ratio was slightly different. Because every element would behave differently than how it does now. So you could say that there's a prime mover, a kind of intelligent designer that set up, say, the ratio to be like that. And other things, Planck's constant, gravitational fields constant, things like that. They are correct so that life as we know it exists. If they were different, it wouldn't be. And there's no fundamental physics theory as to why those are what they are. No one can explain.
They just happen to be.
You can explain how it all happened, not why it all happened.
Exactly. So that's so you can't say there wasn't a prime mover that set it up like that. But there doesn't, at least from my point of view, when you look at the evidence of things like the whole universe, fossil records, the thing I was saying about junk DNA in bacteria earlier, it doesn't look like there's an interventionalist deity in the running of the universe. It seems to run according to the laws of science. But that doesn't prove there's no setup. There is an argument that I'm not personally convinced by called the anthropic principle. Don't know if you've heard of that.
No.
So the anthropic principle is when you have things like, if you look at things like the other things in physics, like say the quantum mechanics, it behaves differently if there's an observer. You get wave functions that collapse onto a point where they can be observed.
It is basically shown in the quantum realm. It is basically predominant.
So yes, and you could say that was kind of all that could exist pre-Big Bang. Was that
right? Okay. Yes, we can say.
Because that can exist without really empty space, which didn't exist before the Big Bang. The anthropic principle, which again I must say I'm not convinced by, is that things like the ratio of a mass between an electron and a proton, and what Planck's constant are such to create an observer, so they could be observed. And we can't. Whilst they could be different, that's not our universe. That's not the universe that we observe. So you'll often hear physicists talk about the observable universe. And that's because we can't be. That's because we can't be sure there's not something we can't observe outside of it all. But I don't think that's a solid. That's again, that's called a principle. That's not even a theory. It's just a principle because there's no proof of it at all.
So it can't be proven. Speculation.
Well, it certainly hasn't been yet. I don't
think in our lifetime we can prove anything.
I think it's a statement.
Any major thing. It's a statement.
Yeah, it's a principle. It's not even a theory.
It's a thought.
Yeah.
But I can observe behavior of something.
Because it by definition is the observable universe, so it'd be very difficult to observe it being different. You can't observe what's not observable.
Right.
Humans are designed in a way to observe that particular thing only, and they can't observe anything out of that.
It's not even humans. Our whole universe is constricted by it. Because our universe exists as it exists now. So if there were different, these values were different.
Yes.
That's not our universe.
This
so
this might be true, but we're not sure. This could be true.
No, it could be true, or there could be a deity, a prime mover. There's neither have seemed to have been conclusively proven to me.
Talk about basically the beginning of the mathematics. So I wanted to ask you how the math actually fits in every part of the other subjects, whether it be physics or chemistry, or to explain each and every concept of universe, math there. So, and it actually began when there was no physics. That I can tell.
Yes, that's
is math discovered or invented?
So yes, that's the question that we can ask.
Is math discovered or invented? It depends on the maths. Some is discovered and some is invented. So for example, the area of a circle is pi r squared. It's quite an easy one. That's discovered, not invented.
Okay.
But a lot of it is invented.
But the value of pi was discovered or invented?
The formula is invented.
No, well, yeah, that way of expressing it is invented. But before human beings existed, circles were still that area.
Right.
So a lot of maths is invented, but that one isn't.
But
Even if
how come that invention of maths put the physics or chemistry in such a way that it actually resonates? So there is
With the
no flaw
universe.
in some sense. With
Well,
universe actually.
well, when it comes to when the way maths integrates into things like physics and chemistry, it's all physics in particular, which I did a lot more of, is all equations. One thing I'd say to people your age, I don't know what your education is, but what you've been educated in exactly. But if you're going to be into physics, especially physics, you need to be good at calculus.
Yes, calculus.
Yeah, you need to be able to do differential integral calculus.
Yes.
Otherwise, you can't do a lot of the physics that will come up.
Yes.
So,
Derivation is related to calculus, and then we get the formula of the physics.
Yeah, you need differential and integrational calculus are two separate parts. Differential calculus, integrational calculus.
Right.
And you need to be good at that. I can't give you any simple tips or tricks to get good at it. You just need to be good at it.
Right.
And my teachers told me that, and I wish I'd listened to them. It made my life easier. And it's definitely true.
Right.
And you get a lot of in physics, when you get a bit more into it, you get a lot of the equations that we know are true. Like Einstein's work is based on things like that, called the Maxwell equations, Dirac equations, the Schrodinger equation.
Yes.
And these aren't simple equations like E equals mc squared. They have integrals or differentials within them.
Okay. Yes. The proof has integral and differential.
It's not even exactly just the proof, the values. So they're difficult to explain simply, these equations. But say the Schrodinger equation dictates how electrons move. And if you want to find out where the electron is, you have to be able to do calculus.
Yes.
It has integrational and differential functions that appear in the formula.
Right.
And that's something that if you can't do or can't do easily, you will then get stuck at this point of physics.
Yes.
You won't be able to actually learn like how all the electrons interact with each other in any more detail, because you won't be able to tell where they are. And Maxwell's equations are things like electromagnetism.
Yes.
And they involve also involve calculus.
So you basically want to say that we observe physics mathematically. So
certainly.
We looked at the physics through mathematics aspects only. We put calculus and we then derived physics, kind of, or the mathematical tools were used to actually come up with the physics idea or the theories.
Almost all of them all come from mathematical tools. Mathematical tools are heavily used in all of them.
Right. That was our question actually. So.
Oh right, sorry. I thought it was, but yes, absolutely, certainly. The mathematics has to come first. Like Einstein, for example, was famous as a mathematician in his time. At least when he was younger.
And Newton calculus.
Sorry?
Newton also gave the idea of calculus.
Yes, well, yes, exactly, yeah. So the Renaissance is what people said, like science suddenly starts speeding up.
Right. At that point of time.
Yeah, and there's a couple of reasons for that. One's the printing press. That makes things much easier because you can disseminate knowledge better. But it's also calculus. Because all the things I mentioned before, like Schrodinger equation, Maxwell's equations, things like that, couldn't possibly have been invented before calculus.
Right. The scientific revolution was the root cause. The root cause for scientific revolution was mathematics only, according to you. Around 70 or 80.
Well, it's largely mathematics. To a certain extent, you can say it's logic, which doesn't necessarily fall into mathematics. When you get things like is 1 + 1 always 2? You need that that's the kind of most fundamental building block, and then you have maths. And then I'd say you then have physics, I would say, and then chemistry comes the next tier up.
So maths is the skeleton of physics.
Maths is the what of physics? Sorry.
Skeleton.
Math,
Oh yeah,
It's
maths
the
is
base. It's the
oh, it's
skeleton.
absolutely yeah. Maths is maths is the skeleton and the skin. Maths is physics is just filling in what's in the middle.
right.
So my maths is weak, so I have no scope in physics.
Well, you can get better at maths.
That's the resolution that he gave you.
Um,
He didn't confront you that if you're not good at maths, you can do physics. So that cannot actually quite happen.
well, the thing is, particularly the harder maths, like if you're bad at like doing your multiplication stuff like that, if you're bad at like multiplying two big numbers together in your head, that doesn't matter.
Okay.
Yes, actually, we have calculated for that.
Yeah, exactly. We've got a calculator now.
You know,
What matters is your ability to understand the things like differentiation and integration, and knowing what you're meant to do next.